It's the last video I'm doing, guys. Unless you have any other ideas or if you need anything else for the final, just let me know. But we're gonna model with vectors, and we're gonna combine these vectors, and it's the same thing every time. A lot of students have had trouble with this, but if you can just get in your head, whenever I need to combine vectors, I always have to write it in component form, and then I just combine and add the components together. It's going to combine the vectors. Okay? Always write it in component form. So a picture of what's going on. 3 people are pulling a piano down the street. Alright, so here's the piano. Person A is pulling with 30 pounds of force at an angle 12 east of north. So east of north is going to be just like this. And I'm actually going to draw in a dotted line. Let's pretend that that is north. So this angle here is 12 degrees. And the magnitude of it is 30 pounds. Person B is pulling 45 pounds of force due north, so straight north. Alright, so straight north. And I'm going to draw that arrow a little bit longer because it's a little bit more force. And then the last person is 35 pounds. What I meant to say was 17 degrees west of north. West of north. Okay. So 17 degrees west of north. And a little bit longer than that first one, and then this is 17 degrees. Okay? So I'm going to find the components of all 3 vectors. So the red vector, that I'm going to call it, that's person A. Okay? So the magnitude of A is 30, and the angle of A is not 12. I'm going to use that angle there, which is 90 minus 12. That's 78 degrees. Okay, the magnitude of B, the green vector, it's going straight north. The magnitude is 45, and the angle, because it's going straight north, is 90 degrees. And then for person C, the magnitude is 35, and the angle is 90 plus 17, which is 107. Okay? Now, the components are going to be simple. And it's the same thing every time. Okay? The x component, the horizontal component, we always use cosine. So it's going to be the magnitude cosine of the angle, and then the magnitude sine of the angle. And I'm going to wait to do that on the calculator when I add them together. Alright, this one is even easier because it's straight north. The horizontal component is 0, and the vertical component is 45. I'm going to use the same formula for this one that I used in the first one. The magnitude cosine of the angle and the magnitude sine of the angle. So, let's see here. A plus B plus C. I'm going to use my calculator and just add straight down. Okay? I'm in degree mode. 30 cosine of 78. I'll use my calculator. I'll take my time here. Mode, degree mode, doesn't matter. Okay, so it's going to be 30 cosine of 78 plus 35 cosine of 107 and plus 0. Okay, so negative 3.40. And then I'll add the y components together. So 30 sine of 78 plus 45 plus 35 sine of 107. 107.82. So I can tell that this has a large vertical component. That's what I was expecting because all of the force is acting vertically. And it's negative, so actually it's being pulled a little bit towards in C's direction, in this blue vector's direction. I was kind of expecting that, all right? So the final angle, this is going to be an inverse tangent of 107.82 divided by negative 3.4. And this is in quadrant 2, so I am going to add 180 degrees to that. Plus 180. It's really close to 90 degrees. I was expecting that. Okay. 91.8. Round to 1 decimal place for your for angles. And I want to use the same terminology that the problem gave me, like east and north or west and north. So this angle, this vector, is going to be in this direction. It's going to be west of north. So it's going to be 1.8 degrees more than 90 west of north. That's a nice answer. Okay? And then the magnitude of A plus of all the vectors combined is just the Pythagorean theorem. And that's the last thing we'll do. Let's see here. Negative 3.4 squared. It should be positive. Positive 11.56. Positive plus 107.82 squared. Square root of that. 107.87. 107.87. Pounds of force, 107.87. So actually, I drew this vector drastically wrong. The actual result, 107 pounds, is more than twice as strong as the green vector. It should be. See how much force these combined vectors have really added a lot of force to pulling this piano, and it's going a little bit to the left. All right, so if they're pulling it down the street, they're going to have to at some point correct and go down the middle of the street. All right, thanks.